Hello and welcome to another session in mathematics. In this session we'll be looking at differentiation, but before that let us take a review of our previous lesson. Welcome back. In the course of today's lesson we'll be looking at rate of change, and then we'll look at velocity and acceleration under differentiation. Okay, for those of you who are in arts, you think we're here to solve science problem. No, we are dealing with differentiation still, but a part of it called what? Rate of change, and then velocity and what? Acceleration. So we'll quickly go over to the rate of change, an example under the rate of change. Okay, we have a problem here on the screen. If the price of a certain product P and the demand for the product X is given by P equal to 2x raised to power 3 plus 3x squared plus 2, find the rate of change of price when the demand is X equal to 3. Okay, this is very simple. For us to find the rate of change of price when the demand is X is equal to 3, all we need to do is to differentiate our P. If we differentiate our P, then we substitute X to be what? 3. And remember, P is given to be 2x raised to power 3 plus 3x squared plus 2. If we differentiate P with respect to X, then we then have what? The P over the X, right? And that will give us 6x raised to power 2 plus 3 times 2 will give us what? 6x, and this is 0, remember? So after differentiating this, we'll now substitute X to be equal to what? 3. Whatever we get as our value is the rate of what? Change. So therefore we'll have 6 into 3 raised to power what? 2 plus 6 into 3. Okay, 3 squared will give us what? 9, and 9 times 6 will give us 54. 6 times 3 is 18. 54 plus 18 will give us 72. So our rate of change is equal to what? 72. Very simple, right? Okay, let's go over to velocity and acceleration. Velocity and acceleration. I will give us a background of these two problems using an example here on the screen. So it says an object moves along an x-axis with known position x equal to s with respect to t to be equal to 15t minus t cube centimeters after t seconds. A, where is the object at time, which is t equal to 2? B, what is the object's velocity at time t equal to 2? C, what is the object's acceleration time at t equal to 2? What is the object's acceleration time at t equal to 2? Okay, for this the first question deals with what? The object, where the object should be. That is the what? The change. Okay, so let us start. Let's go over to the next page. A, the A part of the question said where is the object at time what? T equal to 2. So we are given the equation to be xt to be 15t minus t cube. So we have x with respect to t to be equal to 15t minus t was raised to power 3. Remember, that's what we are solving for. And then we are given t to be equal to what? 2. So if t is equal to 2, we substitute the values of t to be 2 here. So we have 15 into 2 minus 2 raised to power what? 3. Okay, and that will give us 15 times 2 is 30 minus 8. That will give us 22, and we are dealing with what? cm. So that's the answer. Then the B part of the question said what? Where is the object's velocity at time t equal to what? 2. Velocity. We are looking at what? The velocity. Okay, I want to remind us that velocity is equal to change in distance over change in time. Change in what? Distance over what? Change in time. So what it means is just to differentiate our given equation. So if we differentiate that, we then have the x over dt to be equal to, if you differentiate 15 with respect to t, you have 15. Differentiate t cubed with respect to t, you have minus 3t squared. True or false? Okay, and then we are told that the t under the velocity is what? Is 2. So after differentiating, we should substitute t to be what? 2. Therefore, we'll have 15 minus 3 into 2 raised to power what? 2. Okay, and we'll have 15 minus 2 squared is 4. 4 times 3 is what? Is 12. 15 minus 12 will give us what? 3. And we're looking at what? 3 cm per what? Second. Okay, then the C part of the question said what? What is the object's acceleration time at what? T equal to 2. The acceleration means the difference of the velocity. Change what? In velocity. Change in velocity. And what that means is just to take the second derivative of our equation. The second derivative. So C is our acceleration. Okay, so our acceleration is d squared x all over dt squared. Do we now understand? That's why I told you that it is what? The change in what? Velocity. The change in velocity. So okay, it means we should differentiate this again, and if we differentiate that again, we'll have minus 6t, since 15 is a constant and is equal to 0. So 2 times 3 will give us 2 times minus 3 will give us minus 6, then t. Okay, and then we are told also that our t here is equal to what? 2. So if t is equal to 2, therefore we'll have minus 6 into what? 2, and that will give us what? Minus 12. And we are looking at what? Cm per what? Second square. Okay, so that's all about change of rate of change, velocity, and acceleration. So to refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. We'll stop here today. In our next class, we'll go over to integration. So do well to use the lesson note on the platform for better information on what we've just done, and feel free to leave your questions or comments on the comment section. Till we meet again, stay safe and bye.